Alright, so today we're going to talk about growth and decay for your notes. And first of all, to remind you, there's three formulas we're going to do. The two of them are very similar, but you're going to memorize them for the test. So you have, I guess, about a little over a week to memorize the three formulas. But yeah, and the important part about these equations actually, these are how to apply exponents basically, okay? And in finance people and science people use these formulas quite often. So for example, and actually if you're in finance a lot, there's actually a little calculator. They use these formulas so much that you can type in the initial amount, the amount of interest, and how long, and all that stuff, and it'll just come up. I don't know if any of you guys, maybe in your finance classes or whatever, your computer will do it too, where they're like, okay, could I afford this house, or could I afford this apartment, or this car? Okay, and that's the formula they're using. They're trying to figure out how much your payments would be, right? So over a certain amount of time, depending on your interest. And obviously, the cheaper interest rate you can get, the better. Okay, I'm sure you hear that 0 APR. Have you ever heard that on a commercial? 0 APR means 0% financing, okay? In other words, they'll just, the annual percentage rate is 0, so the R in here. So these numbers, or these formulas, are actually used all the time, okay, in a calculator, or that's where the calculations are coming from. So the first problem we're going to talk about is when you're going to appreciate or depreciate money, or a car, or a house, or a painting, or whatever, okay? And let me tell you what each of the things mean. This AT, in other words, the total, okay, is your new value. It's what something's worth at the end of a period of time. And either it will be worth more if it's appreciated, or it's worth less if it's depreciated. Either one. And then this little a is the original amount. And the R is considered the rate. And you always write the rate, guys, in a decimal form. And then the last one, the T is kind of self-explanatory, it's time. Now, I get a lot of questions about why the 1. Okay, and I don't know if you remember maybe back in 7th grade when you studied percent, 7th, 8th, you studied more percentages then, okay? And for example, with your calculator, this is just kind of something to talk about for a second. If I gave you $20 and I said, okay, you're gonna buy something for $20, and let's say that they're gonna add, okay, a 15% tax to it for whatever reason. Okay, to find the tax, you would just do 20 times 0.15, that's 15%. So in your calculator, what's 20 times 0.15? $3, right? So then you would say, all right, it's $3, so your final bill would be how much money? 23. So what they've done with that 1 plus the rate, remember the tax rate I said was 15%? Well, instead, what the formula has done is they've said $20 plus, okay, and they took 100%, in other words, all of the $20 plus 15% more, okay? So if I was going to write this in the form of a decimal, this would be like a 1, and this would be 0.15, agreed? So 1 plus 0.15. That's where the 1 comes from. Now type this into your calculator. 20 times, and instead of 100 plus 15% as a decimal, it's just 1.15, right? Type that into your calculator. 20 times 1.15. What are you going to get? 23. It just, by putting that 1 in there, it allows the answer, this right here, to be the actual, all of the new value. Okay, not just the $3 it rose or the $3 it deteriorated by, but your whole amount. That's where that 1 comes from. It's like 100% plus 15%. Or in other words, 1 plus 0.15. So that's where the 1 is from, okay? It kind of saves us a step, actually. Now, by knowing that, let's try this problem. Number 1, Mr. Sawyer bought a condominium for $75,000. Assuming that its value will appreciate, and that's the difference between, that's why there's a plus and a minus, because if it's gonna appreciate, your value gets more, if it depreciates, it gets less. So 6% a year, how much will the condo be worth in 5 years? So I'm looking for the new price, right? I know the original, I know the rate that it's gonna increase theoretically in the time, okay? So, I don't know the final value, you can use V for that if you want. The final value, it starts at $75,000, right? It's gonna be, the formula calls for 1 plus the rate, so 1 plus 0.06. Or you can just write 1.06, you know, whichever one you want there. And the time is 5. Okay, because the variable is on the left side all alone, all you have to do is type this straight in your calculator. You might want to be sure you're trying it, because I know kids in other classes today were having trouble getting the calculations accurately. Like, they got the equation, but you know, for some reason they're typing in the calculator wrong. So if you type in your calculator, it says that the condo should be worth $100,366.92. I'm sorry. And typically houses do appreciate a little. Do cars appreciate?
No.
No, they don't. Now, eventually, in like 50 years, yes. But, you know, for the most part, cars always depreciate in value. Okay, some cars depreciate more than others and less than others. You can use this formula actually to find out, like, for example, if you want to save money in 5 years, how much money will I have to help you plan for buying a car? That works. You're going to start out with, you know, $3,000 or whatever, and you're going to put it in the bank. How much will it be worth in 4 more years? That's what that formula, and it's not a formula that in real life, like in 5 years, you may want to use a formula and can't remember it. Just Google the appreciation formula. It'll come up and you can just apply it. Okay. Number 2. 7 years ago, Phil paid $40,000 for a car. Its current value is $8,000. Okay, find the average rate of depreciation. So in 7 years, his car went from a value of $40,000 to $8,000. That's pretty accurate. Okay, find the average rate of depreciation. So this time I'm looking for R. So what's the current value, the new value? It went down, didn't it? So the new value is 8,000. Excellent. So 8,000 equals, and the original value is 40,000. And it depreciated. So we're not going to use 1 plus, we're going to use 1 minus R. And this time we don't know R. Over how long? What was the time? 7. Okay, now we're just going to use our algebra skills to solve for R. So remember? What? I know, right? We have no algebra skills. What are those, right? Okay, so we're going to use our algebra skills to solve for R. So what's the first step to solve for R? Divide by 40,000. Excellent. So divide by 40,000. Okay, so 8,000 divided by 40,000 gives us 0.2. So I'm not crowded for space. I'm going to start over here now. So 0.2 equals 1 minus R to the 7th power. That's what's left. Now what are you going to do to both sides to get R by itself? Yeah. Oh, not yet. Good question. If you're going to log, what you're missing would need to be the exponent. I'm not missing the exponent. The exponent's 7. I'm good there. What I'm missing is the base. So we only log if you're missing an exponent. And that comes. Okay? But how do I find R when R is the base? Raise it to the 1/7 power. So you're going to raise this side, which cancels, and this side to the 1/7 power. So 0.2 to the 1/7 is 0.79. This is 1 minus R. Now to solve for R, we're going to subtract 1 from both sides. And you have negative 0.21 equals negative R. So R is 0.21. So what percentage is that? 21%.
Is it okay if we put like 20, if we just rounded it to one place, or do we have to round
No,
it?
you need to round to be more accurate, yeah. Okay, so she's saying that the rate needs to be turned into decimal when you write it in the equation. But you know how they always give it to you in a percent, and then they gave me the answer to decimal, I'm gonna use it in real life back into a percent. Okay, number 3. Number 3. A painting appreciated, so it's gonna go up in value, hopefully, right, if you're a painter. From 3,000 to 4,500 in 5 years. Find the average annual rate of appreciation. We're looking for R again. Okay, so it started off, what was the new value? Not the original. Think about which one's, if you're ever confused about which one's new and which one's original, default to the original. Okay, you always put the new first and the original second. So 4,500 is the new. The original was 3,000. And it's 1 plus my rate, because I know it's appreciating, so I'm gonna use a plus. And it's 5 years. So to solve the problem, the first thing I'm gonna solve for R. So the first thing I'm gonna need to do is divide by 3,000. So you end up with 1.5 equals 1 plus R to the 5th power. So to get R by itself, we're gonna raise this to the 1/5 power each side. 1/5 is 0.2, so you can do 1/5 or 0.2 either way. So I got 1.08 equals 1 plus R. If you subtract the 1, then R is 0.08. What percent is 0.08? Good. So guys, it appreciated at 8%. That's pretty good. Number 4.